They are true heroes of the skies. Helicopters. Designed for speed and versatility, they provide critical support in any scenario. One of the most successful models worldwide is the Bell 429, a powerful twin-engine helicopter built for the most extreme conditions. Manufactured in Mirabel, Canada, each 429 is uniquely tailored. No two are the same.
We like to call our helicopters snowflakes. They're like a snowflake. All of them are different.
The Bell 429 is deployed on rescue missions across the globe. Equipped with a cable winch, it allows for swift and precise extractions.
Walk to the patients or hike or make a terrestrial rescue takes hours or days. By means of the helicopter, we can reach the patient in between minutes.
Bell's European headquarters is based in Prague, the capital of the Czech Republic.
We are like the last before the customer, so we have to be sure that everything is perfect.
In a world where time is invaluable, helicopters provide the ultimate solution. They transport people safely and swiftly, turning every journey into an adventure. As a mode of transport, their superiority is unmatched. More than just flying machines, they're true all-rounders of the skies. Montreal, Canada. Population 2 million. Only half an hour northeast of this bustling metropolis lies the small town of Mirabel, home to Bell's civilian helicopter production.
So we are over 1,500 employees here at the site, and we manufacture all 4 of our commercial aircraft: the Bell 505, the Bell 407, the Bell 429, and the Bell 412.
And production is booming. What makes helicopters unique is their ability to reach places no other means of transportation can. Whenever navigating rugged terrain, remote areas, or open seas, they overcome geographical barriers with ease. The 429 is specially customized for each mission and environment.
We like to call our helicopters snowflakes. They're like a snowflake. All of them are different. They come down the assembly line mostly the same, but then they end up being very different afterwards.
The construction of a Bell 429 begins with cycle 1 at the factory. Here, the rotor mast is prepared for installation, and the transmissions are pre-assembled. Every component comes from external suppliers, including the turbines.
So what comes here is the engine for the 429 from Pratt & Whitney. Here in this department, the employees receive kits of parts that they will tag onto the engine for the engine to be prepped in order to go onto the aircraft.
At the next station, the tail boom is riveted together. This crucial component is made of carbon, a material that isn't the cheapest, but offers significant advantages over traditional metals. Lighter, yet stronger, carbon provides greater durability and resistance. Once completed, the tail boom, which will later hold the tail rotor, weighs less than 18 kilograms.
It has to withstand a lot of force, the forces that are counteracting the main rotor hub. The tail rotor gearbox will be sitting onto this part. It's fairly light, a light part, and they will install it onto the line. But before they install it, they will put all the drivetrain onto it.
Carbon's corrosion resistance offers another major advantage. Unlike metal, it doesn't rust, significantly extending the tail rotor's lifespan. Next, the tail wings and fins are mounted onto the boom. They play a key role in stabilizing the helicopter during flight. A technician installs the core element of the rear rotor, its gearbox. The tail rotor is crucial for maintaining stability and control. Without it, the main rotor's torque would cause the helicopter to spin uncontrollably around its vertical axis. By counteracting the main rotor's force, the tail rotor keeps the helicopter balanced and maneuverable, ensuring precise and controlled flight.
We call the blade in the back blade on the tail boom anti-torque, because the helicopter, when the blade turn, it creates torque. So if you don't have the blade in the back, the whole helicopter will turn around itself. So if something damage on the shaft here, the blade's not turning here, the helicopters will spin around and crash. So it's very important part of the helicopter.
The distinctive sound of a helicopter comes primarily from the main rotor. However, the tail rotor also contributes to the overall noise level. To minimize this, engineers developed a specially designed, ultra-quiet innovation for the Bell 429's rear rotor.
The blade tip here is moving just about supersonically. That's where most of the noise will come from. So this is curved to reduce that effect. We've got bearings here that are laminated metal rings and rubber to damp out vibration. And then finally, with the tail rotor, the actual drive shaft here leaves the main helicopter at 96.4, I believe it is, degrees. It's not a straight 90. All to do with cancelling the noise signature of the helicopter.
In Cycle 2, the turbines are mounted onto the helicopter's airframe. Each weighs around 270 kilograms, depending on the configuration. 2 turbines provide extra safety and performance. If one fails, the other allows for a controlled landing. And while in operation, 2 engines ensure ample reserve power for emergencies.
So it's really a turbine that is translated into a shaft and feeds the transmission. And we're talking about at least 600 to 700 horsepower per engine.
The Bell 429 is a true all-rounder and highly valued by mountain rescue teams, like the Air Zermatt rescue service in Switzerland. In the Alps, where terrain leaves no real alternative to helicopters, the 429 excels.
Especially here in this terrain in the Alps, we have no chance to get to our patients in any other fashion. Walk to the patients or hike or make a terrestrial rescue takes hours or days. By means of the helicopter, we can reach the patient in between minutes.
For these demanding missions, Air Zermatt operates not 1, but 3 helicopters. The 3 Bells are deployed on nearly all of the 2,000 rescue operations they conduct each year. While the powerful twin-turbine engine is a major advantage, rescue teams especially value the spacious cabin, which provides the room they need for critical life-saving work.
We have really a lot of space to work. The cabin is good. For this kind of helicopter, we have a lot of space in the cabin. We have the monitor integrated with a defibrillator, so we can do cardiac pacing, we can defibrillate, we can send ECGs per email directly to the hospital.
In mountain emergencies, every minute counts. With the Bell 429, rescuers lose no time. There's no faster way to reach those in need. In most cases, they descend using a cable winch.
When you have done 4,500, 5,000 rescue missions, it's difficult to take one particular rescue mission out. But what we have is we always remember the last one. And one of my last ones was up at 14,000 feet, where we had up to 60 knots of winds. And we had to rescue a very badly injured climber who fell down 60 meters. So we had to use a 130-meter long rope. And there you try to find the best position into wind where the wind is still laminar. And of course, in this situation, the Bell is such a stable bird, it's an amazing.
Worldwide, thousands of helicopters are deployed for emergency rescues. No other means of transportation is faster or more agile in hard-to-reach terrain. As life-saving aerial responders, they set the gold standard in emergency operations. Prague. The European headquarters of Bell Helicopters is based in the Czech capital. At Prague's airport, 2 large hangars serve as a helicopter hub, where all models arrive from Canada before being prepared for European customers. Assembly, painting, repairs, a full range of services ensures each aircraft is mission ready.
So what we are doing here is a 3 major pillar. We are doing maintenance of the aircraft. We are doing overhaul of components. What we are doing is return to service of the new aircraft and also doing customization of the brand new aircraft for our European customers.
Customers from across Europe bring their helicopters here for servicing, not just the Bell 429. The scope of maintenance depends on the flight hours logged. It can take days, weeks, or even months. Custom paint jobs are also handled at the facility.
Hangar 2 is one of the most advanced and most modern paint shop here, which consists of preparation box and painting box. But also we are doing maintenance, sometimes not heavy but lighter maintenance.
The handover of brand new helicopters is no small event. It takes place inside the hangar, a formal and festive production, but also a time-consuming one.
Even we have a red carpet, and we are delivering the aircraft during even a couple of days because we are training the owner, we are training their pilots and showing all features and equipment of the aircraft here.
Customized equipment is a booming business. Customers get exactly what they want. This model is fitted with new leather seats in 2 colors. While the upholstery process is complex, the installation is surprisingly simple.
For the seats, this seat is used quick release. If you need to take the more cargo or something like this, you can remove all interior about 30 minutes, all interior out. It's really easy.
After all, weight is a critical factor in a helicopter. If the Bell 429's 1,400 kilogram payload capacity isn't enough, the seats can be quickly removed.
We are like the last before the customer, so we have to be sure that everything is perfect.
The Bell 429 was developed in the early 2000s. It entered commercial use in 2010, with a price ranging between 7 and 9 million euros. The 429 has a maximum cruising speed of 286 kilometers per hour, making it one of the fastest helicopters in its class. The main rotor is powered by 2 Pratt & Whitney engines, each delivering 640 horsepower, for a combined output of around 1,280 horsepower. The aircraft has a range of around 750 kilometers and a maximum flight duration of 4.5 hours. One helicopter, 3 basic configurations. The versatile Bell 429 is designed to meet a wide range of operational needs. In addition to its rescue and police variants, it is also used by corporate and private clients. A true VIP limousine of the skies, it caters to the highest standards of luxury and performance.
Die Kunden sind Unternehmen, beispielsweise, die ihre
The customers are companies that need to get their executives from point A to point B quickly. In most cases, they are entrepreneurs with tight schedules and multiple appointments at different locations. And they highly value and rely on fast transportation from A to B, as well as flexibility, meaning they can land directly on site when needed.
Only those with a pilot's license are authorized to fly a helicopter. Training typically takes 6 to 12 months and includes both theoretical instruction and a minimum of 50 flight hours.
Zur Ansteuerung der Rotorblätter hat der Pilot drei
pilot has three control
Eingabeelemente.
inputs to
Er hat
maneuver
einmal
the rotor
den
blades.
Steuerknüppel, der sogenannte
The first is known as the
Cyclic
cyclic
Stick. Darüber
stick,
kann er die
which allows
Vorwärtsbewegung,
for forward and
die
backward movement,
Rückwärtsbewegung, aber auch die seitlichen
as well as lateral
Steuereingaben
control for turning.
für den Kurvenflug beispielsweise eingeben. Er hat den
Then there is the
Kollektivstick,
collective
mit dem
stick.
kann er durch Ziehen
Pulling or releasing it
entsprechendes
adjusts the lift
Loslassen
by changing the angle of attack
das
of all rotor blades
Auftriebselement,
at the same
also den
time,
Anstellwinkel aller Rotorblätter
enabling the
zur gleichen
helicopter to
Zeit,
climb or descend.
einstellen und somit den Hubschrauber zum Steigen oder
And
Sinken
finally,
bewegen.
with the foot pedal,
Und mit den
the pilot
Fußpedalen
controls
steuere
the
ich
thrust of the
die
tail rotor,
Schubkraft des
thereby
Heckrotors
stabilizing the
und kann somit
helicopter
den
along the
Hubschrauber in
longitudinal
Längsrichtung, in
axis in
Flugrichtung
the direction of
stabilisieren
flight,
oder
or turning it as
entsprechend
needed.
auch drehen lassen.
Before a helicopter can take to the skies, everything has to be perfect, including the design. The same applies here. The exterior finish must meet the customer's exact specifications. Whether it's classic corporate colors or extravagant custom designs, anything is possible. Everything but imperfections. That's the company's golden rule. Every part leaves the factory in flawless condition. Even the smallest scratches are meticulously corrected. Here, for example, a tiny speck of dust got trapped in the paint on this door. It's barely visible, but still, the area is polished and sanded again until there's no trace left. Just one haul over, however, it's about far more than looks. This is where safety-critical parts are routinely inspected. Right now, the dampers for the rotor blades are being checked on this rotor head.
If it's repairable, it can be repaired, either replated or individual components replaced. If we take, for example, the rotor head that's right behind me, or the main gearbox of the helicopter, the case is okay. There may be some individual wheels inside that gearbox that need to be replaced. So only those get replaced, not the whole thing. So that significantly reduces the cost of operation.
The more flying hours a helicopter has, the more thorough the inspections. Precision work at its finest. This mast pole connects the transmission to the rotor head. Here, the specialists check for traces of rust on the flanks of the gear wheel's teeth. But the naked eye won't cut it. To spot rust, they use a trick. Two rods are inserted in the spaces between the teeth at opposite points on the gear wheel's perimeter. Then, the men measure the exact distance between the two rods. This makes it possible to determine whether there's even the slightest corrosion with extreme precision.
In this particular case, the corrosion was found to be too deep, and that means the whole part is non-conforming to the standard, cannot be used for flight anymore, and the mast would go for scrap.
Other components are ready for use again after inspection and repair. But before that, critical parts like the tail rotor have to undergo a functional test. On the Bell 429, the tail rotor that keeps every helicopter airworthy is equipped with 4 rotor blades.
It's really down to the comfort for the passengers flying in the aircraft. You're trying to reduce the vibration levels at all phases of flight to the absolute minimum. Not only for the comfort of the actual air crew and the passengers, it also reduces wear, etc., on some of the main rotating components. You know, the smaller the vibration level, the less wear you're going to have. So at all times, they try to reduce it.
And that's exactly what happens next. The tail rotor has been serviced and several parts have been replaced. Now it needs to be finely balanced again.
Now we are ready for start up the engine.
The comprehensive testing begins. The first step, a function test on the ground. The pilot starts the helicopter and revs up the turbines. Once the rotors are clear, he engages the rotor blades, waiting until turbine 2 reaches the correct speed.
Okay, engine number 2 is okay.
With the rotors running, the pilot carefully monitors the temperature and pressure of the turbines to ensure that everything stays within normal parameters. The test will determine whether the rotor runs smoothly or if an imbalance caused by hardware irregularities affects performance. Such an imbalance would be neither visible nor audible, but it would be measurable. That's why the tail rotor is monitored throughout the test.
You can see the cables here coming along the side of the helicopter, temporarily positioned. And they run to this little unit here, you see it? This is an accelerometer. It's measuring the, if you like, the up and down acceleration in inches per second. That data is fed forward to the actual data acquisition unit. They've got a computer. It's working out what those acceleration levels are. It computes how much weight to add to whatever blade of the four to actually correct and reduce that to an acceptable level.
In most cases, just a few grams make the difference. A small washer mounted on the rotor blade is enough. It's the same principle used to balance car wheels. A tiny weight corrects the rotation, reducing vibration and noise for a smoother, more stable flight.
Once he makes the actual adjustment to the weight on the blade, they will start the sequence again. And this time they will check if it's moved the correct direction. They might have to do it again, or maybe it'll be complete for the tail rotor. Then they will move to the main rotor. Yeah.
The test confirms that everything is in perfect order. But now, the weather isn't playing along. With rain setting in, the team has to call it a day earlier than planned.
Okay, so we have a success. So we finished tail rotor track and balance, and we will proceed with other parts with main rotor later on, when guys will prepare that all for them.
The scope of maintenance depends primarily on the number of flight hours. Minor service takes just a few days, while major service, required every 1,000 flight hours, can take months. Back in Mirabel, Canada, the Bell 429 is built in this suburb of Montreal. Many of the helicopter's key components are manufactured and bonded here. But before assembly, every part must be free of dust and residue. That's why the raw components are first immersed in a series of baths, ensuring a clean surface.
They will be cleaned by chemicals. Then after they will be treated, it could be some sort of acid or anti-corrosive before they go to the next stage of either being composite bonded or painted to be completed.
The composite bonding area is strictly off limits for outsiders. This is where the carbon parts are bonded, behind closed doors. The material is incredibly lightweight and durable. Later on, it will be installed on the cabin. But exactly how the components are made, that remains a closely guarded company secret.
So like the 429, for example, it has a metallic skeleton. We'll have roof beams, floor beams, but then all of the side, the tail boom, all of the outside is carbon, and it's load carrying, so it has mechanical properties as well. Compared to some of our older models, many years ago had more metal. Now we're more towards the composite in the aircraft.
The Bell 429 consists of around 1,500 individual parts, not including turbines and transmissions. But before any of these parts are installed, every bonded component undergoes a rigorous inspection. A sonar device plays a key role in this process. The component is placed between two water jets, allowing the technician to see inside and check for any irregularities.
So this machine here applies 2 water jets on each side of the part, and it will detect if there's any anomalies in the part. So it's screening every part by a machine and making sure that there is no non-conformities in the part itself.
Not all helicopter components are manufactured here in Mirabel. Every day, dozens of truckloads arrive from suppliers, keeping the flow of parts constant. But Mirabel isn't just a receiving hub, it also ships spare parts to other locations, ensuring a steady supply chain across the network.
Every week we have a departure truck for Fort Worth and one also for Mexico. Some parts that we build here that needs to go on different sites. Also for Fort Worth we send spares part.
Every incoming load is inspected. Quality assurance is critical when building a helicopter. Defective or damaged materials are filtered out immediately and never make it into production. This process ensures safety and reduces costs. Even the smallest components are carefully checked and documented.
Now I digitalize the part. After that, I can put it in the computer. So you put the CAD model with the scan you just made, and you try to fit them to see if it's as per drawing.
After inspection, the parts move to intermediate storage. In large halls, long rows of shelves hold components of all sizes, waiting for installation. Always in sync with the assembly line's pace. In Mirabel's massive warehouses, some parts move faster than others.
When we receive parts, sometimes they are urgent, so we need to deliver to production now, but sometimes they're not urgent for the moment, so we have to store them temporarily in our warehouse.
From the landing gear to the rotor blades, everything in the warehouse has its designated place. In sheer numbers, small parts make up the largest share, but they aren't sent to the assembly line one by one. Instead, each work step involves a material order that includes all necessary components. Everything needed is loaded onto a trolley. When the trolley heads to the assembly line, hopefully, all parts are in place and nothing is missing.
We pick all the parts we need for an order, for our production order. We put them in the appropriate racking, and then we deliver the whole racking on the floor at the same time.
In Cycle 4, the helicopters finally take shape as countless individual components come together. From this point on, the helicopters go their separate ways. Assembly becomes more specialized. Rescue, police, and VIP versions are built in separate departments. They even use different wiring harnesses. That's why all cables are labeled prior to installation.
To identify every cable in case something happens or a wire gets broken over time or something happens to a wire or a maintenance guy did something to a wire, we're able to trace which wire goes where so they can replace it, put a new wire in.
Once the cables are labeled, they're bundled by hand to form the wiring harness. Each model and version requires a unique wiring setup. Technicians use a template to correctly assemble the different cables.
They have these boards in which they lay out pegs according to the drawing, and then every wire is identified and will be laid out on the harness so that it builds up hundreds of wires in a harness so that when you have your harness, you can install it in the aircraft rather than passing every different wire, obviously.
Sweden. The National Police operate a fleet of 7 helicopters, making it one of the largest Bell 429 fleets in Europe. These helicopters are deployed for law enforcement as well as search and rescue missions across Sweden. Each Bell 429 always carries at least 2 officers on board.
Our crew consists normally of 1 pilot and 1 tactical flight officer. The pilot was in command of the helicopter. Flight safety is his responsibility. The tactical flight officer has responsibility for the police mission, for handling the sensors, the cameras, and the communication with ground units.
The National Police conduct more than 4,500 missions each year. Sometimes this involves more than aerial surveillance. Police officers rely on the helicopter's ability to fly at low altitudes.
The helicopters have a crime-preventing effect because when the criminals hear us, they always think that we see them. In Sweden, if you work on the ground, it's always a relief in some kind of way when the air support unit shows up, because you know that you have someone watching over you and that can relieve your workload in many ways.
At high altitudes, the 429 has another advantage: its near-silent surveillance capability. This allows the unit to conduct covert video recordings and scan crime scenes for missing persons or fleeing suspects. And that makes it less stressful for police officers on the ground.
It solves the missions that we mainly used to do, because we have the capability to carry our mission equipment, carrying our crew, and carrying 1 or 2 extra persons, like if someone is injured or we need to carry out a K9 handler. It fulfills our mission right now.
Sweden is the 4th largest country in Europe. Emergency services often have to travel long distances. No mode of transport is better suited for this challenge than a helicopter. It's no surprise that the Bell 429 is in high demand across Europe. With 100 units in service on the continent, out of 500 produced worldwide. This makes it one of the most successful twin-engine helicopters on the European market. It has also become an essential part of the Swedish police force. Back in Mirabel, Canada, the Bell 429 is built in a suburb of Montreal. After a month of construction, the nearly finished helicopters are pushed into the final production halls. This is where the aircraft are customized.
Either it can be installing an air conditioning or a hoist kit for hoisting people and up and down, or other big avionics equipment tailored to the customer's needs. The aircraft will come in one of these stations here.
The Bell 429 costs between 7 and 9 million euros, depending on the configuration. There's no upper limit. The customer decides everything, down to the color of the leather seats. After all, many helicopters serve as VIP limousines for the ultra-rich. And even above the clouds, these customers expect nothing less than luxury.
Oh, this is just another different color. So this is a beige color. We have black leather, and then we've seen anywhere from red also. So it really depends on what the customer wants.
When it comes to the exterior design, the customer is king, and choices are endless. Painting a helicopter requires careful planning and execution. After thorough cleaning, the paint is applied in numerous steps. First, a coat of primer, followed by an aircraft-compatible paint, which is particularly resistant to temperature and weathering. Once dry, a clear varnish adds extra protection and shine. The result? Unique works of art in every color and with designs ranging from understated to bold and extravagant. But one thing is certain: paint shouldn't be missing anywhere.
We have to do this with the brush after to put black inside, just the finishing.
The air vents under the seats are repainted in the correct shade of black, every detail tailored to the customer's wishes. Christian Palmas is an entrepreneur and wine merchant from California. He's also a private pilot. His Silver Bell 429 allows him to travel quickly and efficiently.
My family owns and operates 3 companies here in California. One, a material science company based in Silicon Valley, and 2 agricultural properties, one Palmas Vineyards here in the Napa Valley, and also a Wagyu cattle ranch in the High Sierras called the Genesee Valley Ranch.
The family enjoys the privileges of owning their own helicopter. No traffic jams, no waiting for a cab. One mode of transport, always ready to go.
I think the defining moment of when we decided to just buy our own aircraft was the flexibility. Being able to not have to think ahead and schedule flights, just to be able to decide that morning, hey, let's go here, let's do this, or I need to be here for this meeting. So that having that flexibility was the ultimate decider for us. You can leave the house, be here in 10 minutes, prepare the aircraft, get it outside, and you're in the air within 30 minutes.
Although the price of around 8 million euros is anything but cheap. And that doesn't even include the costs for private landing pads.
Part of the benefit that helicopters bring is that ability to not be dependent on the runways. The runway independence doesn't just matter at the airport, but it also matters greatly off airport. So being able to have a private heliport with all the capabilities, the hangar, the AWAS, the support there allows us to operate directly to where we want to go. So not having to then add an additional drive from the airport really allows us to effectively manage that property.
His own helicopter. For Christian Palmas, and for many other wealthy clients, it's the perfect blend of flexibility, privacy, and comfort. And of course, it's also a status symbol. Back in Mirabel, Canada, the final sprint in the production of the Bell 429. Before delivery, every helicopter must pass strict quality checks. After all, scratches can happen during assembly. Like this one, on the side window of a door, barely visible to the naked eye. Nobody knows where it came from, but one thing is clear, it has to go, one way or another.
During the process, the mechanics, they need to go inside and outside, and sometimes the door it can just fall, or I don't know, just there's no exact reason, but what we know it's we need to remove it before sending it. It needs to look like brand new, you know.
Many customers wait up to a year for their helicopter, and they expect nothing less than perfection. Luckily, the scratch is on the edge of a side window, meaning it can simply be polished out. A scratch on the windshield in the pilot's field of vision would have required a full replacement. 10 minutes later, the scratch is gone. In the final cycle, the helicopter is refueled. Like most helicopters and turbine-powered aircraft, the Bell 429 runs on a kerosene-based fuel known as Jet A. Up next, the first test run on the ground.
Then the aircraft will come into this station here, and then they will prepare it for its first ground run. So this is the first time that it goes out and starts turning dynamically, okay? The first ground run here at Bell is done with a tie-down tool. This tool, which is right there. We tie it under the belly of the aircraft, and we go outside, and it is tied down, and then they start pulling power and making sure that there is no leaks in the system and everything works well.
Once all flight tests are complete, the rotor blades are removed to prepare the helicopter for transport to the customer. In most cases, using a shipping container. Flight tests are conducted in Mirabel by the company's own test pilots.
We're looking at the basic visual state of the aircraft, making sure that everything seems in order. So the last process is me, the pilot, doing my walk around before going in, starting the aircraft and going for the flight.
Despite his years of experience, he prepares for every flight as if it were his first.
So all the panels are closed, all the doors are closed, there's no apparent leaks or damage to the aircraft. The area around the aircraft is ready for our maneuvers. So I'm ready to go.
Starting a helicopter is nothing like starting a car. It takes more than just turning a key or pressing a button. First, the main computer is switched on. The system boots up automatically and runs a full check of all components before takeoff.
What I'm verifying now is that every system of the aircraft is configured for start. And then I'm going to talk with our control tower to get the clearance for starting the engines. And after that, I will be verifying that every system is working properly before takeoff. So that's going to be my sequence.
The turbines and rotor can only be started once the tower grants authorization. To ensure turbine longevity, they always warm up slowly to reach normal operating temperature. The pilot doesn't request takeoff clearance until all pre-flight checks are fully completed. Then, the tower gives the go-ahead for takeoff.
Okay, so now that my pre-flight checks are complete, I'm gonna roll the throttles on, bring the engine to their operating flight speed, and then soon after we'll be taking off.
The helicopter lifts off and flies. And the principle behind it is actually very simple. The rotor blades spin quickly around a horizontal axis, creating an air pressure differential between the upper and lower surfaces of the blades. This pressure difference generates lift, which raises the helicopter into the air. By adjusting the rotor blade's angle of attack, the pilot controls the amount of lift, making the helicopter climb or descend as needed.
A helicopter has typically 3 different controls. We have the cyclic, which is the handle that you hold in your right hand, and with this, we call it this stick. With this, you control the attitude of the helicopter. So you can push the nose forward to accelerate. You can pull the nose up to decelerate, and you can go left and right, so doing turns. And this is all done with the cyclic in your right hand. So the collective is the lever that is on the left hand, and this is used to create the right amount of power that you need to lift the helicopter in the air and then to accelerate to the airspeed and to get to the altitude that you want to go. The pedals will activate the tail rotor, and this is used to compensate the torque of the engines and also steer the nose in the direction that you want it to go when you're flying at slower speed.
Once the first test flight is successfully completed, the helicopter is inspected again. All checks are repeated to ensure that everything functions flawlessly. Finally, the helicopter is officially handed over to the customer, often including a final inspection and additional test flights. The invention of the helicopter was no smooth takeoff. At Bell, it all began in 1928 when Arthur M. Young, a former mathematics student, set out to build a helicopter. The inventor experimented for 10 years, until in December 1939, he developed a mast-mounted stabilizer, making helicopter flight far more stable. Bell Aircraft took notice and collaborated with Young to develop early prototypes. Success finally came in 1946 with the Model 47, the first civilian helicopter certified for flight in the USA. The Model 47 became a legendary workhorse after being adopted by the US military. 10,000 units were produced in the following years. The fundamental design, with its engine, main rotor, and tail rotor configuration, has remained virtually unchanged to this day.
Well, this is not a 429, it is actually a Bell 407 helicopter. And what we can see here is the top of the aircraft is uncovered. You have the engine with the transfer gearbox, that's the gray piece in there, that drives the mast pole. Then we go back towards the engine, you have the engine itself, and from the transfer gearbox runs a shaft to the tail rotor drivetrain, or a transmission, what we call. That's in a nutshell what you see over here. And again, this is a Bell 407, so on the Bell 429, everything is just a little bigger. It works the same.
With 500 units built since its launch, the Bell 429 has proven to be a remarkable success. Its versatility makes it an all-rounder in the air. It can accommodate up to 7 passengers, depending on configuration and equipment. With an empty weight of 2,025 kilograms, it has a maximum payload of 1,150 kilograms. That brings its maximum takeoff weight to 3,175 kilograms. And in the future, Bell aims even higher. The Bell 525, the largest and fastest civilian helicopter, is ready for takeoff. Maximum takeoff weight, 9 tons. Top speed, 320 kilometers per hour.
On behalf of the men and women of Bell Helicopter, welcome to Heli Expo 2012.
The Bell 525 can carry up to 20 passengers, special forces, or an entire soccer team. Another innovation, the Bell 525 is the world's first civilian helicopter to feature fly-by-wire control. Instead of traditional mechanical rods, this mega helicopter is controlled electronically. Its maiden flight took place in July 2015.
When I lifted off the ground the first time, it almost made me speechless. I mean, it was something I've been looking forward to for a long time. To actually see everything work, you know, and get it in the air the first time, it's a great accomplishment, and not just for me, but for everybody on the team, because I know there's a lot of hard work that's gone into this.
The Bell 525 will be better, faster, and more modern than any of its competitors. It will set new standards as a civilian helicopter. Its fly-by-wire technology remains unique to this day, as does its spacious cabin. It can carry up to 20 passengers. Even transporting motorcycles or medium-heavy equipment is no problem. The Bell 525 will be the 429's big brother, and also a bit more expensive. Priced at around 20 million euros. Interest is already high. Now, everyone is waiting for this next all-rounder of the skies to receive its flight certification and take off. Meanwhile, the Bell 429 remains in service. Customers have been relying on it since 2009. Whether on life-saving rescue missions in the Alps, in law enforcement, or as part of military units, the 429 has become indispensable. And for the ultra-rich, it serves as the ultimate VIP limousine in the skies. Built in Mirabel, Canada, one Bell 429 rolls off the production line each month. No two are alike. Each helicopter is individually tailored to its specific mission, ensuring optimized performance in any scenario. They are the ultimate mode of transportation in the 21st century. And while their maintenance is time-consuming, their unmatched mobility is second to none. More than just flying machines, they are true all-rounders of the skies.